Okay, we're recording. Okay.
Okay, great. I see it too. All right, thanks everybody. Sorry I can't stay today.
Okay, take care.
Yeah.
Do I need to see? Okay. So I think maybe we can just start it. So hopefully more people will come in. So today we only have one talk by Onur Halis. So we may have a little bit more time, but hopefully Onur can control time within a half hour or a little bit more, and then we can have more time to discuss. Onur Halis is a PhD student and a research assistant at Istanbul University in Turkey. Studied glacial geomorphology and physiogeography there. He obtained both his BS and master degree in geography. He's currently a visiting scholar at University of Tennessee, supported by the Scientific and Technological Research Institute of Turkey. His PhD work focused on paleoglacial reconstruction and cirque morphological analysis in the mountain areas in northeastern Turkey. So his presentation today will introduce some initial results of his PhD work. Welcome, Onur. Okay, it's your time right now. I think you can share your screen, right? Can you?
Okay. I sent request.
Oh, okay.
I think that you should stop the share screen.
Do it. Okay. Can you share right now?
I'm trying. Yes, I think.
Okay.
Okay.
Okay. Good.
Thank
Yeah.
you for the introduction, Dr. Lee. I hope that everyone see my screen.
Yeah. Good.
So I am Onur Halis from Istanbul University. So I am visiting researcher at Tennessee University. Hold on, Tennessee University. And today I want to talk about modeling and morphometric analysis of paleoclimatic effects of current and former glacier in northeast Türkiye. I have two advisors from Istanbul University, Cihan Bayraktar, and from Tennessee University, Dr. Lee. This study is support some institutions. One of them, TÜBİTAK, the Scientific and Technological Research Council of Turkey, and Istanbul University Scientific Research Project Coordination Unit. So my presentation content Paleoglacier reconstruction of mountains in northeastern Turkey, cirque morphometry, and pillar reconstruction, and preliminarily result of age determination with Schmidt hammer. I should say that this presentation contains preliminary findings from an ongoing PhD thesis. So I should start general condition in Turkey. So there are 52 mountains with a glaciation. And blue dots indicated current glacier, and black polygon indicates that have been studied by my project team, and this orange polygon indicates that area were no studied before. So I will focus here northeastern Turkey, in this presentation. Because it is my field of study area, I study these mountains from Karagöl Mountain. I hope that you can see my mouse. Maybe from Karagöl Mountain to Kartal Mountain, I study. So you can see name of the mountains here, and also you can see their elevation. The hikes is mountain Mount Kachkar. Reconstruction up to Kartal Mountain has been completed, and from Karagöl Mountain to Kartal Mountain, I completed the model, and glacier thickness and digital elevation modeling data have been obtained. So it is so basic but important question. What is the role of topography in the development of glacier? For this, I credit 7 topographic profile. Profile 1, Profile 2, Profile 3, 4, 5, 6, and 7. So first profile is from Karagöl Mountain to Gavur Mountain. From Karagöl Mountain to Erimez Mountain, elevation decrease, and later elevation increase again. So Kolat Mountain, the second profile, from Kolat Mountain to Demirkapı Mountain, elevation is hike here, and elevation really hikes on the Kachkar Mountains. Topographic profile 3, and from Berçeni Kachkar Mountains to Göze Mountain. So another issue, I create topographic profile from north to south. So from sea level, profile 4, from sea level to Gavur Mountain, there is no blocking barrier to air, humid air coming from the sea, from sea level. So same station from sea level to Demirkapı Mountain, profile 5, and from sea level Kashgar Mountain here, and from sea level to Kashgar Mountain here. So what is current climate today? First map shows that a station with a measurement period of 30 years or more, and second map shows a station with a measurement period of 5 years or more. So at the sea level, you can see temperature increase and decrease. You go up here. So some style precipitation map, and this area has really much precipitations, but you can see amount of barrier effect in the south, and if we go up, the temperature precipitation decrease 1 millimeter at the 3000 level, 3000 meters here. So this is my geological map. There are different units ranging from Quaternary unit to Jurassic unit, and I want to show that box A, B, C, D. This box shows with no surface edge, and you can see here dating method in my study area. And I want to focus box C because I use this area for control point for my Schmidt hammer. So glacier reconstruction, distribution of glacier modeling. The mostly used glacier in Türkiye and OGGM model was used, current glacier model, but there is a new model too, Paleo Ice by Dr. Lee, and I use in my study area this model. So so far, 122 glaciation areas have been identified and their modeling has been completed. I think it will be go up 150. If you look closely from Demirkapı Mountain to Altınparmak Mountain, and closer from Demirkapı, Anzer, Orsor Mountain. As we continue to east, and Kaçkar Mountain, Bulut Mountain, and Altınparmak Mountain, Marsis Mountain, and Karçal Mountain. So far, 122 glacial areas have been identified. So I have mapped some of them. Karagöl Mountain has a smaller glaciation area. I have not finished yet permanent snow line for LGM, but I think that it should be 2,600 meters for LGM. So another glaciation area is Gavur Mountain. So entire glaciation has reached mean thickness 50 meters in this mountain. So this photo from this wave is from here, Gümüştü Valley. So Gavur Mountain. And permanent snow line for LGM in the north, 2,730 meters. For south, 2,800 meters. Total Pela, 2,765. And I prefer to use AABR because takes into account both glacier hypsometry and mass balance gradients. So there are here permanent snow line, and green line shows that permanent snow line for every valley. So Gümüştü Valley is largest glaciation area on the mountain. And other glaciation area is Verchenik Mountain, really is bigger area. You can check it, glacier land, glacier terminal elevation, mean thickness, maximum thickness, area, and glacier volume here. So when we were field work, we determined terminal moraine in the field of study, and later we calculated ABBR and 2,762 meters. So as special area in terms of glaciation conditions, Başyayla Valley. Why I call it a special area? Because there are so beautiful moraines, and they are preserved. Also, glaciation dates back 57,000 years ago in this area. And Başyayla Valley. So I also use this area for control point for my Schmidt hammer. So and I should mention that Black Sea has a great deal of erosion. on the moraine, and it is a big problem for glaciation studying. So before LGM and 57,000 years ago, and 40,000 years ago, and 32,000 years ago, and LGM almost 25,000 years ago. And of course, glaciers gradually become smaller during this period, and you can see here. So, and other glaciation area is Kavron Valley on Mount of Kachkar. The state of glacier 22,000 years ago, and 15,000 years ago. Today we have only small ice and current glacier. And I run paleo ice model here, and it is estimated by paleo ice mean thickness 13 meters on the current glacier. From current glacier photo. So I shows that. And I calculated AABR, permanent snow line. It is 2,785 meters. And another glaciation areas is Ceymakçur Valley, is close to Kavron, close to this valley, and almost same permanent snow line with Kavron Valley. A valley sort of Kachkar, not from north. We call it Barhal Valley. Here is Dübe Valley and Hastaf Valley. They meet here. In photo, you can see here, and Dübe Valley and Hastaf Valley here. They meet here, and there is a lateral moraine here, and also lateral moraine. Another lateral moraine is here, and I used it as a trim lines on the model here, and I run model again here, and I determined AABR again, permanent snow line. It is the valley to the south is 100 meters higher than North Valley on the Kachkar Mountain. So as we continue east, glaciation area is smaller, but mean thickness hike, and also permanent snow line is getting lower as we continue east. So there is a left lateral moraine here, and ABR permanent snow line 2,578 meters. So we have obtained these results, and can we verify it? Actually, it is difficult because I don't have a moraine. I don't have much moraine in my study area because of strong erosion. So we determined left lateral moraine here, and we made measurement in the field. This point has 2,530 meters elevation. It is almost the same permanent snow line here. So another glaciation area in as we continue east, the further east we go, permanent snow line is getting lower in the east, and 2,500 meters and 2,400 444 meters. So another area, Karchal Mountains here, and easternmost mountain, and average permanent snow line is 2,700 meters. So if I comment a very general comment in the west, a permanent snow line 2,600 meters on the Kaçkar Mountain, Mountain 2,700 in the east to 2,550 meters. So what data do I use? Actually, I use 10 resolution digital elevation modeling, but I generate high resolution data too. I use aerial photo. This aerial photo taken by General Directorate of Mapping in Türkiye. So I use Agisov program. So every each blue polygon means that aerial photos. And if you look carefully, there are a lot of points here. Dense cloth, and from dense cloth information, I generate digital elevation modeling. And after digital elevation modeling, I generate orthomosaic photo. And this is a 60 centimeter digital elevation modeling. And if we look closely, we can see detail and more closure. And we can see so clearly moraine border. So I generate ortho mosaic 2, and again I can see clearly moraine border here. So I run Paleo Ice at 60 centim resolution 2 here, and also I use in my PhD thesis circ morphometry, and circ morphometry is widely used in the world, but there is there are limited studies in Türkiye. So until now, I have draft 200 search so far. So analysis on searches are ongoing. I will complete all search. From Ovid Mountain to Verchenik and Başyayla and Kaçkar Mountain, I draft 200 search. I have draft until far. And also edge determination with Schmidt hammer, another issue in my PhD. The surface edge of moraines in this area is known. The moraines with no surface edge were subjected to 40 hammer impacts, and average of each moraine was taken. Here is a Başyayla Valley, and first of all measurement at sites with no surface edge. 24 surface of no edge, and total of 40 impacts, and edge rewind was average every on the surface moraine. So correlation of moraines of no edge, rock hardness value here, and no surface edge here. And as edge increase, the rock surface loses its hardness. So, as I said, I have problem detection to moraine. So detection of moraines in areas of unknown surface H, we used red relief due to limited number of moraines. For example, cirques have high negative openness value and a low positive openness value because they are close to trough. In the case of moraines, their positive openness value is high if the surrounding are open. I use Saga GIS for it. This is negative openness, topographic openness position. This is a positive openness, and there is a circle here, and negative openness is high, and positive openness is low. And you can see here moraine, and moraine has a high positive openness. And digital elevation model here. And I use this formula, positive openness minus negative openness, and divide 2. And after this process, I can get this red relief, and I can see clearly moraine border here. So we use it due to limited number of moraines, and we detect left lateral moraine here. There is a left lateral moraine, lateral moraine, and we determine it with red relief clearly. So in Google Earth imaging. So I use here used here Schmidt hammer. This point this point shows my samples on the moraine here, and 24 surface of unknown H, and R value was read with 40 impacts on the H surface. So correlation process of surface with known and unknown H are going. I have not finished yet. So I can give an example. This rock is coming from Başyayla Valley. We know the surface age of this rock. The age of this rock 17,000 years, but we don't know this surface age. And if the correlation we can maybe we can understand surface age, so we will make a correlation each other. For example, this is age of this rock hardness is 57 value hardness. So this is my glaciation area and my sample, and all hardness values from top to bottom, it is getting lower to bottom. So I can show a video so shortly. With Schmidt hammer. After 40 impacts, I will take average, and I will determine it surface hardness. So we use it in Palaeoclimatic Valley here, and last slides mine. I have a limited moraine, and I use a profile for detection to glaciation area, AA, BB, and CC, for example. And I can understand this is glaciation is area, and CC profile is from river profiles. So result, as a project team, we will collect all data in Glacier Atlas. We will obtain the paleopermanent snow line for the wall of Türkiye. We will obtain the glacier thickness data of all glaciated areas and evaluate all result with the scope of paleotemperature and precipitation relationship. If I have 1 minute, I can show Glacier Atlas too. So. So this is our Glacier Atlas. We will update it after we get result. We will add all result, but I can show something here like this. We have circs here, and we add information. Also, we add circs border, and after all result, we will add glacier thickness, glacier glaciation border, and other result too. So thank you for listening.
Okay, good. I think you finished in 30 minutes, so that's great. So do we have any questions? So for the Schmidt, rock hardness, you just measure one type of the rock, or I guess different type of rock may have different kind of relationship. So you mainly work on one type of rock, or did you test different types?
I use rock Schmidt hammer only for rock. There are two styles in the Schmidt, original rock Schmidt and original Schmidt hammer and rock Schmidt hammer. And I use for only for moraine. It is rock Schmidt hammer.
So you probably mainly use for the granite, right? So the board
Yes.
granite, okay.
Granite. And my control point are granites, and unknown surface edge are granite. Same lithology.
Oh. Good. Yeah, I think the graph show they have some potential,
Yeah.
because this is so cheap. Okay.
Yes.
Any other questions? Okay. So if no questions, I think we can just end. I think next week, it's next Friday, we'll have some talks. I think Ben mentioned that we may change the time. That'll be the last talk of this series, I think. Okay. See you guys.
Thank you so much for everyone.
Nice talk.
Thank you so much.
Yep.